So let's go through the syllabus. This class, we need to get you from here to math, ready for Math 31. So in Math 30, I'm Cassandra Walker. Here's my email. We're going to have Zoom meetings. I'll try to set up our Canvas calendar with all of our Zoom meetings in it. And then I've got my office hour Monday, Wednesday, Friday after class. And let's see, the prereq is a score of 76 or higher on the ALEX exam, Math 29 or Math 29B. Catalog description, functions and their graphs, limits, derivatives. In a second here, I'll give like a big general description on the board of the class. General education. So this class needs to satisfy, or it does satisfy, area B4 of general education, which means there needs to be a writing component. I'm going to make that part of your quizzes and exams, mostly quizzes. We'll have the full sentence responses here and there. Okay, there is a book for the class. It is, let's see, Stewart Calculus. I think it's on like the 10th edition or something. It's an expensive book. You don't have to buy it. I do ask that you buy Webassign access. When I tried logging in myself, it looked like it cost $119, but it does come with the ebook, and it is where I would like to do all of our online homework and tests. So Webassign is the only thing I'm asking you to buy for this class. Let me know if you have concerns about that. I just think it's the best way to do it, homework for moving to online. So for our online account, I was able to link us to Canvas. So in Canvas, there is a module for the online homework. We'll look at that later. We'll look at our Canvas page after the syllabus. So you will be asked to purchase access, but for now, use the free trial just in case you change classes or drop this class. So if you make an account, use the 7-day free trial. Since it's linked to Canvas, once you log in or create an account, you should see our page. If you have trouble with that, just let me know, like send an email to me if you have trouble making your account. I have a good understanding of it, but I also have help from Webassign this semester. Okay, so for this class, I would like to give you quizzes, 4 total, and then there will be weekly homework. I have homework up right now. It's not due this weekend, but next weekend. So just a side note that I always give you at least a week to do homework. I just don't want the homework to pile up. We're going to take 3 exams. We have an exam every 4 weeks and then a test during finals week. And some notes about exams. The test will be kind of like a take-home test. You won't have to show up to class. I will make it a little more strict than your homework. But most likely there's not going to be a time limit. And my idea is that it would be okay to give you a week to do the test. Yeah, we'll stick to a week. I think that'll be okay. So, attendance is not a part of your grade, but I don't always have the best internet connection, so after we record class, it's difficult to load the recording to Canvas. So sometimes our meetings won't be up until the weekend. So if you don't want to fall behind on the lectures or the material, just come to each meeting. And let's go on to the grades. Okay. So I have quizzes as part of your grade. We'll make quizzes on Canvas, or I'm going to make quizzes on Canvas. Homework will be on Webassign, exams are on Webassign, so will the final exam. So everything is on Webassign except for the quiz. Quizzes are 8%, homework is 22%, each test is 15%, and the final is 25%. Okay, question about Webassign. How to do so? You can use any email when you sign up on Webassign. They just need a place where they can give you notices about the homework, stuff like that. So if your school email or personal email, either way, something you can remember. I think we're at the grade scale, which is kind of the usual scale, A, B, C, D, and so on. Let's go here. So comments are, you'll have at least a week to do homework. I have made a homework already, and it's due, let's see, on Saturday the 6th. So homework 2.1. Okay, we'll do this section next class. Today's just a review day, but we'll cover 2.1 next time. 2.1 homework due. Not this Saturday, but next Saturday at 11:59 p.m. Okay, I said I would give you a week to take the test. Same with the final exam, it's just going to be a cumulative test. Anything else? Oh, let's look at Canvas. And this, I have a schedule in Canvas, and then we'll do some notes, and then we'll be done. Here we go. So through to our homepage. Okay, so the homepage is the modules, and the first module is the link to the online homework. So if you click this link here, it will take you to my Webassign account for this class. And that's where you're going to log in and hopefully see our homework and all our class information that's over on Webassign. In the Getting Started module, there's some class info, some of my info, and our schedule, which is what I want to show you. Oh, no. Okay, so I'm trying to get up a welcome back quiz that gives you an idea of if this is the right class for you. It's not graded, it's just like a assessment. Next week will be quiz 1, and then we'll have a week of lecture, then do exam during week 4, lecture, take quiz 2, lecture, take exam 2, and then you have spring break. Do some more lecture, do a quiz, lecture, do a test on week 12, then some lecture and a quiz until we do a final review and a final exam. So if I have time, I do want to make a review for each exam. I just kind of have a lot going on this semester. Anything else to show you? I guess before we leave Canvas and before we do notes, I will put our meetings in the modules. So week 1 will have today's meeting in it, and I'll put a notice about the homework that I made in week 1. Okay, so first I'm going to kind of give you an idea of how I see your math journey through calculus, or how it was for me. Okay, so in my experience, and of course there's a bigger, better explanation of calculus, but when you take a class like Calc 1, Calc 2, Calc 3, it kind of goes like this. You're in Calc 1, and you're in 2D, like x-axis, y-axis, and you've got some kind of function. Some function f. So in this class, I need to teach you how to take derivatives of a function. So we'll do a quick picture. And let's say we're right here and we do the derivative, which is a line that it kind of expresses what's going on right at that point for that curve. Tangent line right there. So that's kind of like the big goal, the main focus of our class. And then you go to Calc 2. And there's a few other topics in there as well, but overall, you've got x, y, you're in 2D. You still have like a function, some function over here, f. And in this class, you do antiderivatives, or integrals. So you find area under the function to the x-axis, like areas underneath your function. On some interval. Yeah. Okay, and then you go on to Calc 3, and you do derivatives and antiderivatives, but in 3D. So you go on and see if I could. This actually, no. So this would be kind of, your plane is flat. This is your x. This is over here y. And another variable z. And you still have some function in there, like just like function, maybe it's over here. And then you do derivatives and you do integrals, but in 3D. So what I want to make sure we know a little bit about is a function. So even though we're not actually going to like study functions, we're just going to work with them. I want to give you notes from chapter 1 that I think are important, notes about functions. So if it doesn't look familiar to you, it's okay. You don't have to have these things memorized. I just want you to be familiar with them. So that way, as you keep on going, if you want to look back, you have a good foundation. Ooh. Yeah, sorry about the internet. It does look okay once you watch the recording. Sorry about. The whiteboard is checking on your guys' comments. Yeah, sorry about the bad internet. We're gonna work on getting a better connection. The recording should look okay. We'll carry on. Okay, let's get started. I'm trying to make my notes a little shorter so you guys don't have to deal with this for too long. So this double bar R, capital R, denotes the set of real numbers. We're going to stay here in this class. We're not going to go into complex numbers. We're going to go up to real numbers, and that's it. Yeah, it's okay. A function. Before we go there, actually, let's do this. A relation is a rule of correspondence between two quantities. Okay, and a function is a relation in which every input has one output. A function. We'll put such that. Yeah, okay. Okay, every input has one output. Again, we're going to input real numbers. We're going to have outputs that are real numbers, or some kind of subset of the real numbers. Okay. We have a picture. So let's write. So your function, let's see. Well, we'll finish the picture and then try to talk about it. So your function is usually called f, but it can be any letter. It's usually some kind of lowercase letter, like lowercase f. Your function takes some input, which we like to call x, and f maps x to the output we call f of x. We also like to call f of x y. It all looks kind of confusing, but this is what's going on. You have a domain of inputs, and the place you map to is called the codomain. And then the outputs themselves, the set of outputs, is the range. We're going to write all that up in a second. So let's put this set here, call it range. Okay. So the domain of F is the set of all possible inputs from R. So all possible real numbers that you can put into your function F. And let's see, I'm just going to tell you that F maps or sends inputs to the codomain, but the range is the set of the outputs. It's a subset of the codomain. Okay, I think that's all we need for that. I think we're gonna skip over some stuff and just go on to the graph of a function. No, let's do, if you guys have some time, we have one example that we'll go over. Let's do this. Okay, function is f. F of x is x squared. So f takes x to x squared. Usually you probably did a table, like inputs, outputs, and just pick some inputs at random, like -2, -1. So f of -2 square -2. Plug in or send in -1, and f takes -1 to f1 -1 squared. F of 0 squared. Put in 1, find f of 1. And then 2 goes to 2 squared, which is going to be 4. So the diagram would look like this. Actually, you can put in any real number. So R. The function is f. F goes from R to, we'll just call the codomain R. And then some subset of the real numbers is going to be our range. Okay, so I just have a few inputs. -2, -1, 0, 1, 2. This is just a little piece of what's going on. So a little piece of the function. So outputs are 4 and 0 and 1. Okay. F takes -2. to 4. F sends -1 to +1. 0 goes to 0. 1 maps to 1. And then F takes 2 as an input, and its output is 4. Okay, I also would like to draw a sketch. So we had input 0, output 0. Input 1, output 1. Okay. We input 2 and output 4. Keeps going on like that. The right inside, -1 went to +1, -2 goes to +4, and it's a parabola. Okay, let's do the domain and the range. Okay, your inputs are the x values. So when you look at the domain and you have a sketch of the graph, you're kind of looking left to right at the variable x. So you can go all the way to the left and all the way to the right, and it's all real numbers. The range is the outputs. We call those y values. And again, if you have your sketch, you can see what y values, or you can look up and down to see what the y values are. So going up and down, you start at 0, include 0, and continue on up. So from 0 to... Let's keep on going. Okay. So those are all, there's a lot of ways to represent a function. Now we want to define the graph of a function. It's the set of all ordered pairs. Something, something, something. Okay. The graph of a function, f, is the set of all ordered pairs x, f of x. So all ordered pairs are all points, x, f of x. What do we have? Such that x is in the domain of f. So it's not necessarily the sketch, it is actually the set. How did I write this? I wrote this in another way, where I let f be a function. So just to restate what's going on. Okay. With domain D. All right, let K be the graph of F. Okay, then K is a set. K equals the set of all x f of x points, so ordered pairs, such that x exists in D. So the symbol we will probably use this semester, it means exists in. Okay, so all ordered pairs x f of x such that x is in the domain of F. Okay. So now I'm sort of introducing some of what we're going to go over in chapter 2. It's average rate of change. So we're almost at the end of all of the chapter 1 notes. The last part is the average rate. Oh, sorry, I missed the chat again. Okay, between 2 points x1 and f of x1, also f of x2, f of x2. An average rate of change between let's see. Okay, is the slope of the line through the 2 points. That's kind of easy. Is the slope of the line through the points, through these points. Okay. So it's also called the slope of the secant line. This is done. And it's denoted M for slope. And then subscript SEC for secant. So slope of the secant line equals the difference in the y values over the difference in the x values. So f of x1 minus f of x2 included over x1 minus x2. So slope should look familiar. This is just specific slope. Let's see, is the average rate of change of 6? Is the slope of the line that passes through the points? It's just a slope. It's also called the slope of the secant line, denoted in secant. It's just a slope. Okay, which means you could also do the slope of the secant line could be written as f of x2 minus f of x1. Just make sure it's over x2 minus x1. So for those subscripts to match when you do your slope. I think we're almost done. I might draw a picture. And then next time we'll come back and we'll start practicing this stuff. We'll talk about tangent lines and secant lines and get into section 2.1. So I've got like a kind of quick sketch. I made my function kind of come over and then down. So we're going to try going like this. Doesn't have to be perfect. So we have a secant line that crosses through the curve twice. Here and here. And then if this, we'll have this our x1 to f of x1 would sit here. And this is the point x1, f of x1 right there. Okay, we're going to call this x2. This point is x2, f of x2, which makes f of x2 some number, correspond to some number right here. And we're going to label this point right here. So, as I mentioned earlier, we have a goal of finding tangent lines. We're going to get there by looking at secant lines and playing with those, and then see what comes up after that. So, I did make an example. Let's try to squeeze this example in. I've got a function. Okay, I picked x cubed minus x, and we're going to find the average rate of change. From x1 equal to 0 to x2 equal to 2. So we're finding the slope of the secant line, m sub secant. Just a slope, f of x1 minus f of x2. Put it over x1, subtract x2. Let's do some scratch work. If you plug in x1, you put it in 0. Oh, nice. Someone got 3. Oh, is that for f of x2? Oh, so when I put in 0, I'm going to get out 0 minus 0, which is 0. When I put in 2, 8 minus 2 is, feeling like I want more work. Okay. 0 cubed minus 0 is 0. 2 cubed minus 2. We've got 8 minus 2. So I'm going to have a 0 minus 6 in the numerator. And then 0 minus 2 in the denominator. Okay. And a negative if a negative makes a positive. 3. Okay. Thanks for your help today, everybody. I hope that I can get this recording up today.